Before we begin, just want to bring everyone's attention, especially for the folks that just got here, to this mentee.com that we'll be using. So this is a way for you to participate. We'll be asking questions, having some polls, some quizzes. This kind of stuff really helps us get an idea of what's going on and what you guys are thinking, and it's a great way for people that maybe want to participate but don't necessarily feel like talking to participate. So so that's that. You can see the code there. Leave it up for a second, and then we'll just jump right into our presentation. All right, so hopefully I have the directions right. Yes. All right, everybody. So today, as you all know, we're going to be talking about APIs, and we'll get more into that in a bit. But before we do that, we'd like to start with some simple introductions. So I'm Steve.
I'm David.
And it's hard to see on this. Oh, no, it fades out. But there's our boss, Bob. And we're from the Western Pennsylvania Regional Data Center. And we're trying to get this pronunciation going. At least I am. I got it from folks at the city.
Whopper.com.
Yeah. So, and just to show of hands, how many folks here are familiar with WPRDC? Okay. And have used our data? Oh, okay, awesome. All right, great. So I guess I really don't need to go into too much detail about who we are, but we're the region's open data center. We help take civic data primarily from government and nonprofit partners and publish it online so that everybody in our region can use it. There's our site.
We have a website that looks like this.
And then here's our plans for the evening.
So first we're going to go over the things you need to know before you can even start working with APIs. Then we're going to talk about what an API is and how to use it. And then we have a lot of real-world examples that we can demonstrate. We have some Jupyter notebooks, some code you can execute, and some exciting things you can do once you get to use APIs.
And then we'll also give you some time to work on your own projects or experiments. That way we'll be walking around, so if you have any questions, you can ask us. And we could offer suggestions on what's maybe different projects, or just if you have you're running into some bugs or something like that.
And then depending upon how the evening goes, we may have an exciting live coding event in the middle, or we may not. That's going to be your choice.
But if somebody has an idea and they don't feel comfortable, they don't think it's too crazy, they don't know if they can do it, but they think it could be done in a night, we'd be happy to demonstrate trying to do it so you can see just how much nonsense there is to working with APIs.
It's all nonsense.
It's a lot of nonsense. And then we'll just have a wrap up. So the one thing we like to do when we give presentations is kind of go back to grade school and do a real quick, just introduce yourself. There's a lot of folks here, so we'll just do it really quickly. So yeah, we just want your name. If you want your affiliation or why you're here, but you can just leave it at your name. More importantly though, a question: would you rather be in a room with 20 guinea pig-sized dogs or one rideable guinea pig, like a horse-sized guinea pig? So I'll start. So my name's Steve. I'm with the WPRDC, as you know, and I'm going to go with the guinea pig because I feel like people are probably going to go with the dog most of the time, and I feel bad for them.
I also want to ride the guinea pig. Maybe we should start with this table and then kind of work around.
Ben, C student at Pitt, and definitely one rideable guinea pig.
Yes.
Rebecca, I am in transition, and I'm going to go with the dog.
I'm Tom, I'm an engineer. I'm primarily on the water resources field, and I'd pick the rider. I want to ride one. When are you going to see that?
I know, seriously.
Okay, I'm Victoria. I'm a technical project manager, but study mechanical engineering. I would probably take the dog. There's just more of them, so.
My name is Tim Dolan. I work at the Community Development Nonprofit Hilltop Alliance. And I'm going to go with the rideable guinea pig because I don't like tiny dogs.
My name is Matt. I am not working right now. I'm just kind of doing my own projects. And I would go with the dogs.
My name is Samantha. I work at Home Children's Village as the research evaluation manager. I was going to go with the dog, but my mind has been changed, and I'll go with the thing I won't see anywhere else, and I'll ride the Hannah, I'm a communications assistant at the data center, and I have to go with the
Rob, I'm with the regional data center. A clarifying question, can I pick the dogs, but also breed them with other small animals, so we have like dog rabbits?
I mean, I don't know if you can breed cross species, but there is a horse-sized guinea pig, so sure. Yeah.
Cool. And I just want to say, like, we got the seats over here, so pick the walls.
I'm Alexa. I'm also a communications assistant with Data Center. I would definitely go with dogs because it's one of my life goals to one day be covered in dogs. I'm Katie. I'm a UI designer at Telegram, and I would have to go with dogs. I'm Jean Marie. I'm a service design expert, and I would go with dogs. So I like dogs.
I'm Zach. I'm the data intern at Expert PR Station, and I would go with the small dogs.
I'm Potter. I'm just a hobbyist. I would pick the virus guinea pig.
I'm Naz, and I'm actually a student at CMU. And I'd go with the 20 guinea pig sized dogs because I can place, a lot of them like at whichever place I want them to. Otherwise, if I had to use the rideable guinea pig, I'd have to ride it everywhere.
Hi, I'm Akash. I'm a Spanish player. I probably take the guinea pig that I don't like dogs.
Hi, my name is Nikhil. I'm a student at CMU. I'll go with the guinea pigs, the guinea pig size dogs.
My name's Ryan. My company's called All Vision. I think I'm going to go with the rideable guinea pig just because I need to know a lot more about this type of dog and stuff like that.
My name's also Ryan Garrity, Forward to Food Rescue, and I would go with the rideable guinea pig because you're in a room with it, and I think that'd be awesome.
I'm Ellie. I'm a web developer, new to Pittsburgh, so looking for opportunities and just freelance on the side. And I would choose the room full of puppies because puppies.
Hi, I'm Carly. I am a front-end programmer for a startup up in Blacksburg. I would go with the one rideable guinea pig because it's a lot easier to deal with one angry animal than one.
Hi, I'm Darshan. I'm a grad student at CMU, pursuing chemical engineering, and I would go with the 20 guinea pigs.
I'm Kevin. I'm a student here, and I would go with the dogs because I've been bitten by a guinea pig before.
I'm John. I'm a web developer, and I'm going with the guinea pig because, among other things, I believe that less is more.
Hi, I'm Masha. I'm a project manager, and I'd go with the dogs for nobody reason.
I'm Tyler. I'm a front-end developer. I'd go with the dogs because 20 dogs of any size can be bad.
Okay, and then there are people around the periphery that I think we didn't get. Let me start back there with you. We can start over here with you and let her finish swallowing.
Which of you? Aaron Morris, founder of a cool company startup in town called All Vision. Talk to me later if you want to know about it. You know what? I was going to go with guinea pig, but the line for that's going to be crazy long. So I think I got to go with dog.
My name is Brandon. I'm also at All Vision, and I would go with dogs. I babysat a guinea pig once in my youth, and the idea of a larger one is a nightmare. Yeah, that's nice.
I'm Tony. I would go with the guinea pig because 20 dogs in a room, if it's not a big room, there's just too much dogs.
I'm Maria. I would go with the dogs. I have a couple with the tiny dogs. I have a couple over there.
My name's David. I'm operations manager at Active Like America. Since horse-sized duck is not an option, I'm going to do the rideable guinea pig.
Nice. We should be keeping numbers.
My name is Julian. I'm a bioinformatics intern at Git, and I probably go with the one.
My name is Zach. I have a pot-bellied pig instead.
Hi, my name is Tess. I work as a software engineer for Uber and I would definitely do the right way.
So Mark, one of the original code for people, and I'm not a tech person.
Okay. None of you both.
I'm James. I'm a automation engineer at US Bank. I'm also a code manager for the that takes 20 king size dogs.
I'm Melissa Nicholas. I work out in Money Plans, and I would go also with the. Hi, I'm Ellie. I do data stuff for Allegheny County. I would take a report groups and I'll talk about options. There's also at least 5 or 6 chats, so if you don't listen to everything, you should send those actually.
And anybody who just came in who wants to introduce themselves, answer this important question here. You guys? Yeah.
My name is Shabazz. I work for BNY Mellon. I'm a full app developer. I haven't read that yet.
We'll get back to you about that.
My name is Ahmad. I work with BNY Mellon as an application development.
Okay.
All right. And now David's going to go back and recite everybody's names to him. Okay, so now we're going to take our first mentee break.
I'm ready for it.
Well, no, a little early on that. Okay, so this is just for us to get an idea of kind of like what familiarity people have. Yes?
The question is the password for Wi-Fi.
Oh.
I don't think there's a password.
Okay, never mind.
All right, so if you came in late, you go to mentee.com and enter this 6-digit code here. You can answer these questions, contribute.
Okay, good. We're seeing a lot of Python, which is great because that's what we're going to do a lot of stuff in. Yes, Fortran. Someone put MIPS in. Nice. All right, so looks like things are repeating around here. So we got a lot of Python, which is great. That's what we're going to be covering a lot of, and JavaScript. So this is more for us, but it's also just kind of fun to see. But, oh man, it just keeps on going. All right, so I'm going to move to the next one here. So this is just kind of like, how comfortable do you feel with all of these different statements? You know, you feel comfortable with using Python, so on and so forth. Once again, this just helps us get an idea of like what stuff we can move fast on. And once we get to about 25, I'll just move to the next one. Okay. Kind of makes sense. Wow, okay. Now we're blowing up. Maybe 30 will be the answer, the number. All right. Whoever put a 1 for WP, ooh. Oh, that's upsetting. All right. All right, so now we're about to have a quiz question. And, oh, got to go back? Thank you. Okay, sweet. Thank you.
Okay, and to explain the scoring on this trivia,
I see.
We should note that the faster you answer, the more points you get, assuming you get the correct answer.
And there are prizes at the end of the night. All right, so I saw like 34 before. Okay. Anybody else? Oh, wow. Okay. All right, good. Everybody should be in now. Anybody having any difficulty? All right, we will just go ahead. Speak now and play the game. All right. This one's an easy one. Get people warmed up to the concept. 5,
Okay, I think that's everybody.
4, 3, 2, 1. Nice. All right. Okay, so now back to our presentation. We'll see the leaderboard after that. All right, you want to do this one? Yeah, sure. So, okay, so the one thing we want to do real quick is just kind of give like a really high level understanding of an API before we go into the nitty gritty basics and work our way up. So one way to look at it, and I kind of don't, well, I'm not going to get into this, but all right, is to look at it like a menu. And in that sense, it describes the things you can get out of the service in that case, or like the restaurant, and what it takes to get those. So that's, I mean, probably like the simplest way of putting it. So now we're going to go into the background. This is where we're going to start with some of the nitty gritty stuff. And I just want to let everybody know we're going to be going, there's a whole lot of information that we just couldn't put into this. So we're going to touch on things very briefly. I don't want anybody to worry about like making sure they retain all of this or have it perfectly. Like this is just to kind of show some terms to you, get some things in your head so that when you see us do the examples where like the real like meat of this presentation's at, you'll have heard these terms before. So don't stress out about like things going too fast. And also, if you can see here, watch out, David, there is a link to our GitHub repo if you want to take a look at it. Everything, the slides are there. Every example we use is there. We have a whole bunch of resources there, so feel free to look at that when you're done. That's where like a lot of the work will be done. All right, so APIs exist on the internet, and as you know, here's the internet, or also that's me in 1994. So, and just I'm sure most of you know this, but the simple way to look at the internet is just a massive network of interconnected clients and servers, and those are all just pretty much computers. And they communicate using a protocol called HTTP, which stands for Hypertext Transport Protocol. I'm sure most of you have heard the term before, maybe you're not super familiar with it, but HTTP at just the simplest level are the rules for how like information is transferred, how communication is done over the internet. So we have a diagram here where you can see like this is a client like your phone, your tablet, your computer. It sends a request to a server. So this could be like a server that runs a website. That server says, oh great, this person wants a website, builds the HTML of that website, shoots it back in a response. The same happens with API requests. You send a request, an API request, using HTTP for web APIs. That goes to a server. A server says, oh, this person wants to either do this or get this data. It does that thing or collects that data, puts it in a response in a format that's easy to read for a computer, and we'll cover those shortly, and sends it back to your client, and then your computer handles that, whether that's code you wrote yourself or your web browser or some app that you downloaded or purchased. So all of these HTTP communications are built out of these HTTP messages. So the one thing we just wanted to cover is, what are the simple parts of this? Because some of it will, affect when you're dealing with APIs at a high level. So the first thing is you'll send a request, and every time you send a request over HTTP, it puts this whole bunch of text over here with it. So the first one just says, hey, I'm making a GET request, which is a type of request, and we'll go into detail on those in a second, for hello.html, which most of you are familiar with would be like a web page. And then it has a whole bunch of headers, and this is like the metadata of the request. So it says like what type of thing your client is. In this case, it's like probably like Firefox web browser, the host, which is just example.com. If you were hitting our website, it'd be like wprdc.org. And then a whole bunch of others. There's tons of headers there. We have links in the documentation. There's pointless to go over them all, but then they pretty much explain just different things about the request. It's a great way just to think of them as like metadata, where they're not truly what you're transmitting, but they describe what you're transmitting. Then also, once you do that, the server, if you're lucky, will send a response. In this case, it sent a response with a 200 OK, which says, hey, I heard what you're saying. Here's some stuff. It's all good. It also has a whole bunch of headers. And these, once again, are like metadata about what it's sending. And finally, it has a request body. And this, if you're going to a website, when you make a request for a website, that website is in the request body. So the server builds the website, makes HTML, sends the HTML file in that body right there. And there's also a case if you ever to make what's called a post request, and we'll explain that, you will put data in the body of your message as well. So you heard me mention Git and Post, and these are the two big HTTP methods that you'll probably use in most of your like beginning to use APIs. Honestly, like, I mean, I deal with a lot of web APIs and I don't use much else than those. So Git is a request, and it's telling the server, hey, I want to get something from you. It's probably the one you're going to use the most because it's something you can use in a lot of like public APIs or like free services, because it's just you're getting information from a service. And it's, but don't let, you know, there are things where you do have to have an API key to get that information for like private information or people that want to track your usage so that you don't like just go crazy. And so, yeah, generally that's used, if you think of this on a high level, as a way to understand the state of things. And that sounds kind of like hand-wavy, wishy-washy, but like it's super vague because there's just everything on the internet uses, like in some way or another, probably has like a web API, so that things could be anything. And what you'll use is you'll use the URL parameters to specify your request. And we'll have a specific example of this later, but those are like if you've ever seen like the question mark and like a variable equals something and at the end of a URL, that's what this is. And then post, if you want to cover post?
No.
Okay. So post is what you do, was the method you use when you want to send data to a server or request it to do something. So this is used more often with services you pay for in some way or another. And it's used to change the state of things. So this could be something where you post to a server and tell it to change some of the data on its server. So when someone goes to get something, they see that change you asked. Or it could affect change in the real world. And I seriously mean that. For those of you who've ever used like Lyft or Uber, you know, you use that app makes a post request to a server, I'm assuming. And then that server then sends some message to a person in a car in your neighborhood, and then boom, they're driving that car to you. So it's that post request affected change in the real world. And when you send post requests, you put the data in the message of the body, so in this big chunk of data that you send.
Okay, so we mentioned the Get and Post are the main requests that you're probably going to be using. We just wanted to briefly mention that there are a bunch of other much more obscure ones. And the only one on here that I use on a regular basis is head. And a lot of servers, if you do a head request for like a file, it will give you the metadata about the file. And I use this to get the size of the file without actually downloading the file. But the other ones, I don't know.
Yeah, I mean, sometimes I use put because it's put or patch because it's just a way to either just like, especially for people who use there are people really serious about the semantic, like the real meanings behind these, and so they actually care. Like if you're going to put data somewhere, use put. A lot of people are just like, forget it, just post anything you're going to move somewhere. And then patch to like modify stuff. I mean, I know like in one example, there's definitely specifically put requests that we'll look at. And then we get into status codes. Now, a lot of you have probably seen a lot of these. There's a whole bunch. We have links in our documentation on our GitHub there if you want to see. But we'll just kind of go over what the general cases are. So anything that begins with a 2, so in the 200s are successes. So that, in most cases, you want to see like 200. That means like everything went perfectly. You should get exactly what you expected. And I think I got everything that you expected to send to me. 3 is a redirection. Still pretty successful. Usually what happens is it's saying, hey, you tried to get this. It's not here right now. But if you go to this link, it'll come back with a different URL. If you go here, that's the thing you were looking for. And this is really great with web crawlers and mainly like search engine spiders, because that way, like if you move a web page and you have the old web page do a 302, I think, request to the new one, Google will know, oh, that site that everyone was going to and that they searched for and that I put in my search results is now here, and it'll switch it once their robots see it. Which is great, because if you just moved the web page before, it'd get lost until people started going to it again. Then 400s, I'm sure everyone's probably familiar with these because they've seen 404 not found. But one you'll definitely see a lot, I know I do all the time when dealing with APIs, is 400 bad request, which means you asked the server to do something or you asked it for something, but you screwed up how you asked for it. Like whether you like you didn't format your request properly, or you asked for something impossible, that kind of stuff. There's 403 forbiddens you'll get if you weren't allowed to use that service. So you might have to prove that you're you, or maybe you have to like be in a certain network to actually access some of those, and that's kind of thing you'll get. And then there's 405 method not allowed, which you might see, which is when you use the wrong type of method. So if you're trying to like get data but use a post by accident, and vice versa. And then there's server errors. There's nothing you can do about those as a client. If you're running your own services or like host your own servers, that's something you have to deal with. But a lot of times if you see one of those, there's not much you can do. That being said, there are some times where you might see a 500 error because you sent a request that the server thought it could handle but couldn't. So it didn't warn you and say, hey, buddy, I can't do this. But then it died trying to do it, and then it gave you a 500. But hopefully you don't come across that.
And finally, there's the dreaded 666 error code, n times detected. Please don't get this one.
Also, this image does actually represent 2 of our examples, as you'll see. All right, so I think the next thing we'll talk about are these common response formats. So what happens is when you make an API request, that body message is either most likely going to be the XML or in JSON. Now, these are just 2 of the most popular ways to represent data and send it, over the internet. So XML, like a lot of people probably heard it, a lot of people have probably seen it, and if they haven't specifically seen XML, they probably have without knowing it because HTML technically is just a subset of XML. So if you've ever messed with HTML, you can see it looks very much the same. And what it does is it chunks this data up. So you have this whole thing is a person. This is that person's name. That person's first name is Steve. That person's last name is Sailor. Their employer is the Western Pennsylvania Regional Data Center. The location of said employer is in Pittsburgh. And their coolness is a 10. What's missing from this data is that that's out of 100. And then, so this JSON object over here represents the same data. So as far as a computer's concerned, as long as it knows how to read each of these, the data, it would think about these both the same. So this, you can see, this in these 2 curly brackets is the whole person. The name, first name being Steve, last name being Sailor, so the name's this object in here in the curly brackets. The employer is this part in the curly brackets, name WPRDC. An interesting distinction here is XML allows for these attributes that allow you to put something in the tag. But you can't do that in JSON. It needs to be a simple matching of a string to some sort of data. And since you can't do that, you have to make this attribute its own thing. And then coolness, you see here coolness, and then there's an actual number 10, unlike these that are all strings. And once again, still out of 100. So now we'll take another mentee break. Should we get a vote on this? So even though for those who aren't very familiar, just from what you've seen, which one looks better? All right. So now we can show the winner. Yeah, that's right. I hate XML. Okay.
The scoreboard.
I wonder why it's like behind on this. Wow, it's a real tight race. All right. No, I think I got rid of it. All right, and let's see. Boom. All right, most people got it right. Still, this is some good competition. I like this. All right.
feel the tension in the room.
All right, and nice. All right. I think, yeah, Truman shows holding up at 1 point. All right. And that should be attributes. I typed that wrong. But all right. Yes. All right.
This is the most important question.
Yeah. This one's actually for the most points. Like, no, normal size, like medium-sized dog. The more important is what does the dog do for a living? All right, so let's show the winner here. And it is B. Okay, that's right too. All right. All right, so now back to the presentation. So this is the what of the meeting, the presentation here.
All right, what actually does API stand for? Application Programming Interface. All right, we talked a little bit about what it's going to do. So we talked before about how it's kind of a menu. You have a question? Okay, like this? All right. We talked a little bit before about how an API is sort of a menu of the services that something offers, maybe a website. We're talking about web APIs here. And a lot of people start off their tutorials about APIs by saying that they are like Lego bricks in the sense that they are modules that you can put together easily to form something. We think APIs are like Lego bricks because they hurt when you step on them. All right, I already told you. Another example of an API would be sort of like the Windows operating system. It has an API, and historically there were documented and undocumented parts. So mostly what we're dealing with today are web APIs that are well documented. That's sort of the state we live in now. So this is a very simple example of an API request. You can type this into your browser, and we're going to break down the components now. The first one in turquoise is just the root URL for the Western Pennsylvania Regional Data Center's data portal. The next blue part says go to version 3 of the API, specifically the action API. There's other things you can do in the API. Then data store search in orange, that's the endpoint. This is the particular item on the menu you're picking out. Then there's a yellow question mark that's saying the rest is going to be the parameters that we're passing to this endpoint. And there are two parameters here. There's the ID string, which says which element in the data store are we searching for. And then there's the limit, the number of, the maximum number of results we want to get. And they're separated by an ampersand. So if you have a bunch of parameters, they're all going to be separated by ampersands. So that's a GET request. It's a very simple one.
All right, so another just general topic, something you'll have to deal with when dealing with APIs is authentication. And just in general, that is proving that you are you. So in cases where, you know, myself particularly am allowed to access data, like, you know, modifying things at the data center, I need to prove that I'm me. And to do that, I have a secret key that lets me do it. So, and like I said, that's for things like privilege requests, changing stuff. Also, maybe if you want to like ask a server to do something, they're going to want you probably to authenticate, because if you're telling it to do something a lot, they don't just want people to be able to do that willy-nilly. They need to like keep track of it, know who's doing it, and then if they do too much, they can rate limit them and just stop them and say, hey, like you got to wait an hour before you can make another call. And each site and each service handles this differently. So some of the more common methods are a simple API key in that authorization header, in that HTTP header. So this is how we do things at the regional data center. So when you make an account on our website, if you look on your account page, there's an API key, and it's just one of these big like hexadecimal UUID strings. But you can just copy and paste that in a header that says authorization, and then our server will know, hey, you're this user, and then based on what privileges you have, it'll let you do whatever you're allowed to do. Except for like a handful of people in this room, it's no different than not using an API key because we're an open data portal. So by default, as just accessing it, you can do anything you could unless you're an employee. But that's the one way. Another way is using something called OAuth, which just like really simply uses a third party to pretty much say you are who you are. So you may have seen situations where you've logged in with a Google account or Facebook or something like that, and that's how that works. I hate having to like deal with it programmatically, but it's not a problem. And then sometimes there's just people that will accept your username and password in some combination, and that can happen in a bunch of different ways. And I'm not going into any specifics because this will be different for everybody, which leads us to the next slide, and probably the most important thing, documentation. Once again, this is me from this year, reading some documentation. And so documentation, like all the good APIs have documentation on the web. And it's very important that you read it because otherwise, I mean, it's just a shot in the dark of what you're doing. And then in the documentation, it will list like all of the endpoints, what they do, what kind of information you can send to it, what can you expect to get back. And the really good ones have code samples. And that means like you could pick a language of your choice and get some examples that are usually decently documented. You can follow along with their examples and really kind of learn by doing. And then some of the even better ones have consoles that you can experiment in that allow you to use a graphic interface on the web to just kind of toy around with their API a little bit, to just kind of like experiment and see what it does before you really start digging in and writing code around it. And always, put this in yellow, always read the terms of use. You want to make sure you're not doing anything that someone will eventually come back and sue you for. So, I mean, usually like they should be on top of that themselves. If they're offering something, they should limit it in some way, but you never know. All right. So now we'll just do some general big examples of things that have APIs that are relatively easy to access and you can do fun things with. So the first is Spotify. The Spotify is great because it has like nearly everything I think that the platform is built on, you can access through the API to a certain extent. So you can get information on songs, albums, artists, users, playlists, everything. And that even includes the features they use to classify songs for things like their Discover playlists and daily mixes, and like the summer rewinds, all the machine learned playlists they make about you. You can see all the features they use to do that machine learning, and it's awesome. And it's got really crazy stuff like danceability scales and all that kind of stuff, speechiness. And then it also has the actual like what's the term? But I mean, it has very minute like measure by measure details of the songs and like what's the most common pitch during that measure. It's insane. So people are into music, it's really cool. And then you can also kind of get the status of like your player session. So like if you're playing on that's how like when your phone you can control your you can see what's going on your desktop with it and then you can post. This is where you can control the music. So if you hit a button on like your phone and control it playing on your desktop or something like that, and it allows you to like build and modify playlists. And there's a whole bunch more. It's pretty insane. The next one is just a little topical. I saw this on Hacker News a couple days ago. Someone made a World Cup API that allows you to get like stats. I think it's like pretty good. It's like being up to date And it has a lot of information, like teams, different matches, players, and it keeps up to date pretty well. I think you can pretty much follow a match on it in some way. And so like, here's a little quick example here where, yeah, if you go to their like country endpoint where you can search matches by country, and then there's, it asks for in the one parameter to be the FIFA country code. Ours is the United States, so when you search it, you get nothing because we're not in the World Cup this year. But if you actually pick a country that's in, there's this massive amount of data, and it's pretty cool. And I don't even like soccer, but it's interesting. Another huge one is Twitter, and this is one we'll have some examples on. So in general, I mean, there's a lot you can do, but the really big things are it lets you read tweets and it lets you tweet tweets. And by read tweets, I mean, you can search tweets by users, hashtags. I think you can even actually do like text searches like you would in a search bar. It's pretty nice. And then the posting's great because, I mean, you can just have a bot that posts tweets at like your favorite or least favorite politician, Bob, or at WPRDC. We'd be happy to receive them. And then another one is Twilio. So this may not be something a lot of people have heard of, but Twilio is this service. You have to pay for it, but they do have like a $10 free tier that they give you $10 for free pretty much. But what it does is it allows you to do stuff with phones. So they give you like one of those, like I think it's like 5-digit numbers that you like sometimes will get like service text from. And so with that, with the Git methods, you can either read text that people send to a number. So it'll take those numbers, the text that people send to it, store in a database, and you can get those. Or you can like have people be called and then enter like, you know, press 1 for this or even say stuff and record those responses and get that data. This is like great for surveys and stuff like that. And then you can post to have it send text messages to people or make voice calls. And you can either use pre-recorded like WAV files or using their own special markup language called TML, you can have it like do robot talk over the phone with text to speech. And you can do it in a British accent, which is kind of nice. Another big one is Reddit, which once again, the entire service is built atop the API that they have publicly available. You could just take, I mean, I think the website itself I think it still is. It used to be that it was really big about the fact that it was open source. So you could like clone the entire thing if you wanted to. And so the entire API, the back end is exposed. You have to OAuth in to do a lot of things. But once you do that, you can get posts and all the information, metadata about it, all different comments, subreddit information, and user information. So some of the cool things you could do with this are, especially with like natural language processing, where you could, you know, read what kind of comments and what kind of posts get like the most votes and stuff like that. There's a lot of cool stuff going on that along with that. And there's a lot of great people that have made some cool bots that do stuff like summarize the news or like reply to people with Wikipedia articles about like, you know, famous people and stuff like that. And you can do all that with the post and put methods that allow you to make posts or leave comments, make subreddits, and upvote.
All right, so the Port Authority of Allegheny County has what they call a true time API. They're tracking all of their buses now, and you can use this API if you get an API key to find out for a particular bus stop, when are the various buses coming. They even predict the arrival time, although they're not totally accurate. I think we should try to improve that a little bit. You can search on bus stops and get detailed information on the bus stops, where they're located. And for individual buses, you can find out how fast they're driving in a particular moment. I think that's not totally reliable, but maybe you could poll it like every 30 seconds to kind of average, and which way it's going.
And actually, just another thing too, I was just messing around with this last night. There's a new version of it that has even more stuff that we'll have to, I didn't have time, but we'll get the documentation.
Okay, but we have a Jupyter notebook, and we're going to allow you to, if you have the key or can get one fast enough, to play around with that tonight.
And we'd like to share the documentation, but it's behind a login, so I don't know if we're allowed to, but we'll figure that out.
Okay, so the regional data center has our own API. We're very proud of it. It's based upon CCAN. You can list all of the data sets we have. You can search for data sets by the name or by tags. And then you can go in, and once you've picked a data set, you can drill down into the data. You can pull all of the data for a particular data set. You can pull subsets. You can do queries. So you can say, I want all of the 311 requests for a particular category, all of the potholes, and all of this stuff will be spelled out in notebooks. And as Steve points out here, those are the GET requests. The POST requests are stuff just that we and publishers are doing.
All right, so on top of that, we've taken the API that was available in the data that came with the data center with the platform is called CCAN. You don't need to worry about that. That came with its own API, and we've built some things on top of that. So the first one is the aptly named property API. So what this does is it allows you to search for all the data across the data center that relates to one parcel. So if you're really good with SQL, you could kind of make this yourself and like send SQL queries that do that. You'd also have to like personally keep track of all the data sets that come in with this stuff. So we've taken all that off you. So there's just a URL, and we have documentation there where you go there, search by a parcel ID, and there's some explanation on how to get those. And then you can find anything. Right now there's like assessment values, recent real estate sales, building code violations, liens, foreclosures. There's a whole bunch. Property is probably like our most rich category of data sets right now. I'm also working on something very similar with the neighborhood API where you can aggregate data across the data center related to a neighborhood. So I kind of want to do a very similar thing where with the property data, aggregate all of this information at a neighborhood level and just say like, oh, what's it like in Shadyside, and get that. And of course, all this data is updated daily, hourly, some of it minutely, and then monthly, and that'll just change live when you go there. So you can build apps on this, build dashboards, tools that'll change live when people look at it. But right now, it's just got census data and some aggregated assessment data that I'm using for a tool I'm building. But I plan to add a lot more to that. And then there's our Geomancer, which is like a little mini GIS service. So it's not super powerful. It's mainly used for a lot of stuff I do, but there's a lot of really simplified. So you can't do a lot of the nitty gritty GIS stuff, but if you want something simple, like to get a list of the regions in the area, and then so like municipalities, neighborhoods, stuff like that. And when I say that, like you say, what are the municipalities? It gives you all of them and some geo information about them. And then use that to maybe find like all the parcels in a region, which is the last one. So that helps you go back to property and get that data. But we also have some really basic like geocoding addresses. So you can type in an address and get a latitude and longitude. Or reverse geocode, where if you have lat longs or an address, you can get like all the regions that exists in. So like, if you picked like this building, you get neighborhood Friendship, municipality Pittsburgh, and stuff like that, which is just mainly just helpful for doing analysis without actually having to get your hands dirty with GIS. So here's another mentee break through the wall. This is for our boss who's has a borderline unhealthy obsession with Kool-Aid Man. Thanks. Oh, here we go. We get another recap on where people are standing right now. Nice. All right. All right, so we're about to start the next question, so everybody get ready.
Okay, a lot of people got this one right. Next, okay, no. Standings.
Wow, True Show's really holding on.
Yeah, very tight. Okay, next question.
We were running out of questions. Nice. No potato.
All right. Finally, we have something a little more interactive. We're going to give you a few minutes at this point to discuss at your table or with whoever's sitting next to you what you'd like in an API. Is there something you'd like an API for? Is there something you know about already, an API that you would like to do something with? And then as you get answers, and you can put multiple answers in here, please submit your answers and we can discuss them later.
Yeah. In general, we're looking for like stuff we can come back after this and say like, oh yeah, well there's a lot of great information for this that you can go to, or here's some more information about that API, just trying to help. Dog Tinder. Bob, you can't give these ideas away. It was one of Yin's, wasn't it?
It was Alexa.
It was.
Yeah, I know.
Yeah.
And rainfall and hydrologic stuff. Yeah. Yeah. I know there's like weather. Yeah. So I want to be able to build a GIS. Get text alerts when a threshold is rainfall. So there's certain trigger points in the region when things become problematic. Not landslides, because those are harder to predict. Mainly flooding problems. No, basically just let people know that potentially there might be an issue here within this part of the. So I have access to all the rainfall data. I want to be able to quickly turn that around. Live actual time frequency, and then be able to send text. Or pull it up on an or pull it up and see. But that would be my purpose for being to take the API and do a more active more specific, one that's more, rather than just like a blanket one across the whole county. But yeah, you might be up here on a hill, or it's really more important if you're down on Washington Boulevard or somewhere next to a river or a tree. Yeah, I don't know, that's the question. At least it would be able to, if we were to get the alert on maps, to be able to go to a map and see where is potentially more. I mean, it's not the end all be all just because you're not in the red area, you're safe. It's more of like, these are the areas that are really potential.
We got a lot of work cut out.
Most people aren't familiar with where flooding problem. I know as part of my profession. So it's like, how do I?
Ooh, that'd be kind of interesting.
I feel to communicate that. You can sign up via sign up my phone.
All right, I think we should probably. All right.
Hey, disclaimer, by the way, I'm not. This is not the. Yeah.
All right, everyone. We're probably just gonna get back to it in a couple seconds here.
National Weather Service. Text alert.
All right, this is awesome. So right now we're just gonna kind of run through these so everyone can see, but then we'll hopefully talk about these a little bit later. We'll pick out some ones we definitely know people can work with and kind of just mention some stuff. So I'll do my best. Whoa, oh, that's kind of cool. Didn't know that happened. slowly scroll. Yeah, I don't know what happened. It was just like, yeah. Maybe I didn't hit that setting. Yeah. Add a loss. All right. Back to the presentation. All right, so now we're going to discuss the how of all of this. So these are going to be just a couple of tools to help you access APIs. So the first one, if you're really into using terminals, the command line, you're really comfortable with that, this is for you. And if you're already there, you've probably used it before, it's curl. And curl, I'll kind of highlight here. You run the command curl, and then the endpoint you're trying to hit. So this one is using our Geomancer API to geocode our office address. And this V is just a verbose flag, so it prints out some more information for me for purposes of this image. So because I put the V in, it prints the headers here. So here you can see the request line, the request headers, and then where these arrows are coming back at you, you can see the response headers. And then after a little space where it puts some extra information here that's from curl, you see the like raw, really ugly, hard to read as a person JSON. But if you're a computer, this is great.
Ugly, but at least it's not XML.
That is true. That is true. And also, like if you're Go terminal, like you can pipe this into something that pretties out the JSON. But we're not going to get into that in this presentation. Another thing, and this is something I use a lot. It's a tool called Postman. It used to be a Chrome extension, and now I think you just you download it by itself. And it is like there are so many features that I haven't even bothered to use yet. It's really great if you want to you can do a lot of testing your own APIs and stuff with it. But if you're also just kind of screwing around with somebody else's, it's great because it's like curl where you can put your requests up here. This happens to be a GET request, and if you hit this params button, which I should have taking a picture of that now that I think about it, it puts down a nice form of parameter to value. So you don't have to type it in like a string. You can just kind of see exactly what you're doing. Hit send, and then it'll give you the response down here in a nice, pretty, annotated, colored version. Except the fact that this happens to be an XML. But besides that, you can see all the data right here. Or you could use your favorite browser, like Internet Explorer 6. Or a normal browser for nowadays. A modern browser, I guess, is the correct term. And so in this example here, it's hard to see, but I went to another one of our other Git APIs right here, and the JSON response shows up in the browser. So if you do this on yours, you'll get this ugly, unformatted JSON response that's hard to read. But you can use in Chrome and Firefox are these JSON viewer extensions that give it nice colors so it's easy to see what's what, and indents it and stuff like that, and then puts a little bit of metadata up here. One warning about this is it does give you this helpful, it tells you the data type for complex data types. So this is an array with one object in it, and this is an array with two, which is a pain if you're trying to copy and paste this because this is not part of JSON. It's just for you to look at. So you can hit this raw button over here and then copy and paste it. But this is stuff, and this and many more horrible things you'll find out as you start to experiment. And then after that, there's some programming libraries that make dealing with HTTP requests and thus making API requests a lot simpler. So you want to do this one?
Yeah, sure.
Yeah.
So I use requests a lot because I program in Python. And the examples we have tonight in Jupyter Notebooks are mostly in Python, so they rely on requests quite a bit. It's a very nice library, and it's a very convenient way of getting and putting HTTP requests. But if you're interested in other programming languages, there are others, like JavaScript.
So building a JavaScript in most browsers, I think I saw somewhere that you have to get around it if it's Internet Explorer, but I haven't dealt with Internet Explorer in a long time, but I should check that. That you can use their fetch API, which is also the other like Windows API version of the term API we were talking about, not necessarily like the web API. Even though it's dealing with the web, it gets really confusing. Let's not worry about it. But it's like requests, where it allows you to make HTTP requests, and then that return data you can easily build into your JS code. So for those of you familiar with JavaScript, like there's a lot of asynchronousness, so or asynchronicity, I guess, where when you make the fetch request, it's not going to wait for the data to come back from the server before it starts doing more, like working on more lines of code. So you have to like take the things that are going to handle the request in a callback. Like it's going to return a promise, and when that promise resolves, it comes with the data. Well, it comes with the response, and then you can get stuff from that response and build the data. You'll see an example in like 5 minutes that'll help a lot with that. But once again, it's just got built-in functions that make getting data and using it a lot easier and building it into your code. And then finally, there's AI wrappers, which are libraries in whatever programming language you use that are built entirely around making requests and interacting with web APIs for specific people. So like, there's probably people who've written like a Python Spotify web wrapper. There's a great, and I recommend it, Python wrapper for dealing with CCAN, which is the Western Pennsylvania Regional Data Center. That way you don't have to like think too much about HTTP. You can just say like, hey, I want this data set, or I want to get this from this data set. And it makes a lot more sense. It feels a lot more like the language you're comfortable with. Semantically, it just makes a lot more sense looking at it.
I'll also add that for anybody who uses R, there's also a CCAN wrapper for the wrapper for the CCAN API in R, and we've linked to that from the README for this event.
So yeah, there's they exist in a lot of languages and for a lot of things. And also, like if you start like dealing with a lot of APIs, maybe in a specific language for someone's API, and there's not a wrapper, and you kind of like, well, you want your code to be like pretty dry. You don't want to keep like doing the same thing over and over again, so you end up writing your own. Put that on GitHub. People will love you. Get a lot of stars. If people actually use that API. And then this just happens to be me about 1,000 years from now. Hopefully. So now we're going to jump into the big part of this, which are live examples. So in that case, we've got a Jupyter notebook here. And for anybody that was here last 2 weeks ago for Eleanor's awesome talk, she introduced Jupyter notebooks. If not, we'll kind of go over what we're doing here. But what it is it allows you to run, in this case, Python code, and you can kind of see what's happening as you do it. It'll make more sense once I start doing it. And of course, I hard-clicked that. So can people see what's going on? Is that good? Let's see. It's a little bit. There we go. Okay. So we're going to start with some really simple examples here. Does anybody have a problem reading that? Okay, great. So the first example we're going to deal with is just this this cat API I found on some GitHub repo of fun open APIs. And I'm just going to use this to kind of do the really basic stuff so you can see some of the terms we mentioned before in action. So as you can see here, I'm importing that request library we just talked about a couple slides ago. And then I'm also importing this IPython.display image thing. You don't have to worry about that. It's just there's going to be pictures coming, and this makes it so we can show those pictures on Jupyter. And then this little thing that deals with XML, and I'll get to it and we'll see. So the first thing is that base root URL we were talking about. This is the host. So it's the catapi.com. So this is the server that we're going to be hitting and making requests from. And the main endpoint we're going to use is API/images/get, and this is where we're going to get images. And hopefully most of the APIs you deal with will make this much sense when you read them, but they won't. So what we do is we're just making the request URL by combining that root base URL with the endpoint. And so when we run that, boom, got the catapi.com/API/images/get. And then if we make a request, so if we use request.get, and then request, so we use the get and make a GET request at that URL we just made and run it, we get this response object. And you can see 200, that's the status code, which means things went well, and this presentation hasn't bombed yet. Things are about to get a lot hairier in a bit here. But All right, so we can look at the content of this. So that is that response body that we talked about. For the request library, they just call it content. Now remember, I said these were images, so it's going to look ridiculous because it's a hexadecimal representation of all the bits in the JPEG image. So that's kind of annoying. So we'll just actually turn that into an image. So we use this image thing, and that's what we got. We made that request, and we got this picture of this cat with the paw on its head. So let's see, we can do that again, where we can make another request and make another image. So in this one, we're going to make a new request, and every time you make a request, it's going to get you a different image. So if we just do that, oh, it's Control on Mac, and we get this cat GIF. Do it again. We get this cat with face and bread. Get a cat with glasses. Get a cat in space. I'll do like one more. Cat playing the piano. Okay, great. It's perfect. So that's great. I mean, getting these random images of cats is fun. But there's more we can look at here. So one of those is actually using some parameters to specify what we want to get. So I have links here, but they send you to the documentation on, we'll do an example so people can see what decent documentation looks like, because this is just someone's like pet project, pun intended. So here's the API endpoint where you're at, and then it tells you, here are the parameters that you can send. So I've sent none, which is fine, and it just gives me a random one. But you can do things like use an API key, which I think is used for like doing voting and stuff like that. An image ID, if you found a specific image you liked and you just want to keep getting it. What kind of format? So I set none, so it gives us a picture. You could get it in XML, HTML, no JSON, sadly, which is a big thumbs down. It is the #1 most requested issue on this repository. Results per page, stuff like that. So you can specify how you want your data to come. So we looked through that, and then we found that if you look, I'll go back real quick. There's this category thing, and it says values is this complete list. And if you go there, it sends you to this list endpoint. So we want to get this list and see what kind of categories we can get. So if we go here, we get the category endpoint is category/list, as the doc said. Make that URL by adding it to the end of the base URL. We get that. We can then make a request for it, and then we'll print the text that it gets, and it's an XML, and it's kind of annoying. But here you can see all the data we got from that list. So we got categories like hats, space, funny, sunglasses, boxes, Catterday, etc. Ooh, ties. But there's a lot of great stuff in there. And what we can do is then we can send that category as our category parameter. So I'm going to pick hats. So here what I'm doing is I'm building a, for those of you familiar with Python, it's just taking a Python dictionary and having it say the category is hats, the size is large, and the format is, we're getting rid of XML. We're not going to deal with that. Well, no, we can just do that. And this will give us all pictures of, this will give us all the URLs of large cat pictures in XML. So it gave us one right here. But we can just, instead of actually parsing that XML, we'll get rid of this. And hopefully, unless I broke something, well, I don't know what broke there, but it's like, it's waiting on the request. So either way, we won't be able to get a picture of a cat in a hat, but there will be more pictures of cats shortly because we will jump to the Python or the JavaScript version of this. So this is pretty much going to be the same thing, so I'm going to speed through it as fast as I can. And it won't let me zoom. Great. But hopefully you can see this. And this is using something that is really new. It's in beta. It's from Mike Bostock, the guy that made D3, for those of you who are familiar with it, called Observable. And it's like a JavaScript version of Python, in a sense, for the sake of this presentation. So you can do the same thing. Like I set my base URL to be the cat URI, cat API, hit enter, and it stored it here. I did the same thing with the endpoint, built the request URL, and then in this one, I stored the raw image data by using fetch. Now I used await, so for those of you familiar with JavaScript, for those of you who aren't, don't worry about this. Like, I found it a pain to actually deal with like asynchronous stuff and promises in here. So I was just like, just screw it, we'll just do wait. And what it does is it takes whatever happens there, puts it into this data. So this is the raw cat picture. And then I use their little image thing to make the cat. And so these examples are all on our documentation. So once again, here you can see the URL here, cat API, images get, category equals space, size equals large, and it got us this large picture of a cat in space. So these are something you can play around with just to get the basics. They're all on our, the repo that we have linked at the bottom of our presentation. And then next is, it's this one, isn't it?
I'd like to go back to the presentation.
Yeah, go ahead.
Okay, so just to give a little context and build up for the next example, I want to first ask, who in the room knows who this is? Yes, got a few hands. Okay, so this is what we call foreshadowing. When Ellie and Melinda asked Steve and me to come up with an API workshop, we sat in my office and came up with some ideas pretty quickly. And then I said, I'd like to do something even cooler. And Steve said he knew that there was a way to order pizza through an API. So that's what we're going to do for you now.
So,
oh, this is the Noid, by the way.
For those who didn't know.
The Noid destroys pizzas, except Domino's pizzas.
All right, so yeah, I think this would be a fun example of showing why things won't click right now.
Are you zoomed into it?
No, I have no idea. I'm going to get rid of, oh, you know what? It's this cat API. I broke something here. There we go. Hopefully killing it killed it.
This is not the live coding stunt we promised earlier.
No, but we could do that. All right. There we go. Okay, so thankfully, some nerd on the internet, and I mean that in the best way possible, reverse engineered the Domino's API because it's not public, and built a node module that would make pretty much order pizza with Node. And I was like, that's cool, but I kind of want to be able to just do it in any language and show people, just the actual, endpoints and everything HTTP. So I had to reverse engineer that to build this, and eventually I'm going to document it so anybody can do this. But we'll be pretty quick about this, but we tested it again. We tested it last week. We tested it again today. I'm going to have pizza again tonight, probably. I'm not even a big fan of Domino's Pizza, but they're the only one that has this service. So this is what we have to do. But anyone who's familiar, you've probably seen, at least on their advertisements, they have like that tracker that like shows you like, hey, it's in the oven, it's on the rack, it's in the car. All that data, I mean, because that's on the web, I mean, that's an API being hit. So that's pretty much what made me realize, oh, someone's got to have that. Of course, someone did, thank God, and we can do this. So the first thing is just importing all of our libraries. So those of you who do a lot in Python will be used to this. So yeah, these are all libraries. This is pandas. You're probably wondering like why. Anybody who's ever done like data science stuff is why is pandas here? You'll see why in a second. But pandas is like a data science, like just like data mining, not mining, but like a way to just deal with big chunks of data and mess around with it. And then and there's a lot of warnings here, but there's a secret settings file that's not in the repo that has credit card information and other personal information about myself that's required to order this.
Should we change the address?
Yes, we should. Crap. Well, we'll do that we'll do it live. In the words of Bill O'Reilly, we will do it live. Okay. So, and then this is just a little helper function called pretty print that we just set up a pretty printer to print our JSON so it looks pretty. Otherwise, it's a little bit hard to read. So here are all the API URLs. So I just really broke it down so when you like look at this in your own time, you can see how it's all made. But I'm just going to build all of the different endpoint URLs out of these. And then before we begin, we need information. So this is my personal information. This is fine to share with Yins. So it is wrong. So we got, this is our office. Everything else is right, except we're going to use, do you have my Google Voice number? So yeah, now here's my number out there if anybody wants to send mean texts. But we can do, all right, we can modify. My address is equal to, what's the address here, Justin? 5648 Friendship. What? Okay. They're going to call me. All right, 15206? Yep. All right, sweet. Yeah, hold on 1 second. All right, so we'll update my address to be the Code and Supply address. For some reason, you have to put commas between everything. And then phone. All right, it's going to be 412-879-0398. All right, sorry about this, folks. So now we've updated this. We can check it again. That's what's great about Python. Jupyter. So we can see, all right, 5648 Friendship Avenue, Pittsburgh, PA 15206. That's me. That's the Google Voice number, right, David, right? Yeah. Okay, sweet. So now we have that. That's what we're going to send when we make our request. So then what we need to do is we need to find the closest store to this address. So they have a store locator endpoint, and it takes 3 parameters. S is address part 1, C is address part 2. I think it's probably like apartment or something like that. I haven't toyed with it, so I don't know for sure. And then they're going to call anyway, so we don't need addresses. And T is type for delivery or carry out. So we'll set this up. So these will be our Git parameters that we send to this request. We'll make a request.git to the store finder URL that we built earlier, and then send our parameters, and then we will pull up that data and print it. All right, so we can see it gave us a thing, the address. That's the address here. And then it gives you a list of stores. So it's stores here is the key. There's a list. And then the first one is, okay, that's it. 109 North Sheridan, so by Target. Gives you all the information about the store right here. Does allow carryout. Just recommend actually just screwing around with this yourself and taking a look because it's a lot of information. So it gives us a whole bunch. So we're just going to take the first one, and that is the one at Target. So this little object here represents the Domino's in East Liberty. So what I did here was just to make my life easier, I pulled the store ID out of it. So you can see store ID 4710. Boom, there we go. All right, so now what we want to do is we want to see what's on the menu there. So you can do request.git to the store menu URL. This is the problem with their API. This one works a little bit differently, and I guess I should go up and highlight this. It doesn't take Git parameters. It's more like a RESTful service, which we haven't even touched about, but like it says store, then in the URL you put the store ID, and then you can get the menu, which is kind of weird that they've got like, it seems like there's like 3 different development teams that built their web services, and none of them really communicated. But thankfully it works. Hopefully it works, I should put it that way. So yeah, here's the menu from that store. And I don't know if you can see my scroll bar over here, but it's ridiculously massive. So we're not going to deal with that. So we'll just take a look at one item here. So this is what like bread twists look like. Parmesan bread twists. They have a little description, everything. And that's cool. There's still a crap load of items. So what we're going to do here is I'm going to use pandas to just make a quick little table of all the items in the menu. So that huge JSON response loaded into pandas, for those of you familiar with it, we're able to just make this cool little table. The only problem is there are like 200 some items, so there's this big ellipsis in the middle that cuts out most of the important items like pizza. Yeah, we go from salads, who cares, to sides. It's nonsense. So in my own time, I did a lot of filtering. I don't think I saved it to this, but I found the pizzas I wanted. Oh, here we go. And then, no, this isn't it, but I found the pizzas I wanted, And then I was like, oh, what kind of options can I get? So I looked through the options, once again, came back in JSON, loaded it into pandas, and we got this nice options table. So this is where you can see things where like, you'll have an options object and you'll say X equals 1, which means I want the robust inspired tomato sauce. Or PM equals 1 for I want Philly steak. And this is how, like if someone like a POS there, like when they enter that information, gets all sent to some computer, probably in a very similar fashion. And then, all right, so we have, so then what we're gonna do is we're gonna build my order. So this is like the massive object we're gonna send in a post request. So this is gonna be JSON text that we load up into the body of our message, send to them, their computer's gonna take it, read it, realize what I want, and then soon after I send the credit card information, send a human being over here to give me pizza. So, what? It will. It should be, wait, can't use your address? Oh, you're right, it is, thank you. Woo! That would have been fun. I would have had to drive to the office real quick. Wow, how did I do that? Let's see. This is what happens when you test at the same location. You test under the same circumstances, it doesn't really matter. All right. So we'll do, we'll change that to me address. Nah, actually no, we'll have to just, I don't feel like parsing that, so we'll just break it apart manually because it'll be a lot faster for everyone's sake. All right. Sorry about the delay here, folks.
Justin, does he need to use address, secondary address?
It'll be all right.
Yeah, I actually don't know how their API works with the secondary address, but I never used our floor, and they just came to the building and called me. Let's see, Pittsburgh, all right, 152206. We don't need any of that because that's all taken care of. All right, but the rest is still there. Yeah, my first name, my last name, my email, my hopefully Google phone now. And all right. So then what we're gonna do is we're gonna make that request. So this is a nice thing too. They offer you an endpoint that lets you validate the order. So if you're ordering from your smart TV or your Xbox or your Alexa, they'll check to validate your order first and let you know like, hey, what you're trying to do is nonsense. So here I sent the request. It came back with this JSON object that gives me a whole bunch of information like who I am. It made up an order ID for me, even though I'm not gonna order it yet. It says like, oh, hey, that's a 12-inch hand-tossed Wisconsin 6 cheese pizza with robust inspired tomato sauce. But here's the important thing, status 1, which as far as I can tell so far means it's good. Because there is no documentation for this yet. And it'd probably cost a lot of money and pizza and calories to figure it out. But I might be willing to do it. Okay, so now that we have that, I feel like there was one thing I wanted to do, but I think that should be fine. Do we want to change the order? Do you want to make it 60-inch?
Yeah.
Okay. Luckily, I've learned a few of the codes in my day because they're indecipherable. But this is where you'd put the options. I guess you should go back now that we fixed that. This is our store ID, our service, method delivery, and then we say the products we want. It's a list of different objects. And so this is a product. Its code is this. This is that 6 cheese pizza. Options, that's where we'd throw in like Philly cheese and stuff like that. And it'd be like something like X is 1 would give us tomato sauce, which is our default, so we don't have to worry about that. And how many of them we want. So 1. Anyway, we'll just validate that again just because I'm OCD. All right, great, that works. So then we'll price the order. So what this does is it does the whole validation request again, but it returns a price. So I'm just gonna rip the price out of there and give you a whole bunch of amounts like pre-tax and post-tax, but there's this customer one, which is how much we owe. So I'm gonna get that, and it says we owe $25.12. All right, perfect. So then, we will use definitely not my credit card information. And so that is just an object that says like it's a credit card, it's a MasterCard, Visa, Discover, whatever. And like this is the number, this is the secret, 3-digit code, this is the expiration date. And then we just add to that object, because that's how they expect this request to come, the amount key, and put the price, and the type is credit card, even though that should already be in there, but just in case. And I'm not printing that, and hope to God it works, because then we'll just have to figure it out from there. Okay, so now what I'm going to do is I'm going to do this validate order, which I don't know why, because it's just going to stress me out, because it's going to come back false, because I think I realize that you can't validate with credit card information. That's fine. Now here is the real thing and why I have this code commented out, because if you run this, it's going to order a pizza. So this will make a request, will post a request, make a post request to their place order URL with all this order object I build up by adding my credit card information, the price, and the order and everything. So I'm going to send all that information to them. They're going to come back with a response. I'm going to take that response, steal the order ID, because I'm going to use that for tracking. But then I'm not, because I'm going to just use my phone number. This is vestigial. We don't need it anymore. Then I'm going to delete the payments object from the thing they returned so that I can show you what they came back without doxing myself, hopefully. Oh no. Yes. Hold on. Yes. All right. So in 20 minutes, I'm going to get a call. There'll be a pizza here. And hopefully none of my payment information is in there, but we're not going to risk it. But there's a whole bunch of cool information explaining, what's up with your order. And Domino, yeah, at least it's a different number now. They're not going to wonder why I'm eating so many pizzas. So then here they have this tracker, which is on trackweb.dominoes.com. And this is where their website's tracker is. So boom, we have all this. It's nonsense to read right now, so that's fine. So I'm just going to take some stuff out of it. And what did I do wrong? Uh-oh. There we go. It just... Bob! Yeah, I thought somebody had died. I could have been pizza, I guess. All right. So in this case, now we're hitting the tracker. Yeah, is that the time? Yeah, right. 7:35. Yeah. So that's.
The order status is make line. The pizza is now in the make line, whatever that is.
Yeah. Sorry, what? Okay, so this is the response that came back. It came in XML, so we parsed it using this XML to dictionary library. And then, so we got that, and that's cool, but like, what are you going to do with that? So what we're going to do is, since there's only one of those for this number, we don't need to treat it like an array, which is also really bad on their API. Because the last time I did this, there were two responses for me. So what it did is it gave me a list of things. And this time it just gave me one thing, not like one thing in a list. So when I went to access it, my code broke because the actual structure of what I was receiving changed, which is bad practice and the kind of nonsense you're going to see a lot. But, all right, so let's see. I think everything else should be just fine there now that we have the data there. And then we built this little tracker code here. And there we go. So this is going to slowly check the order, the status of our pizza, and add more dashes and emoji depending on what stage of development my pizza's in. Really high tech right here. But yeah, the hot spring is, I guess, the oven? I thought that was the rack. It is the rack. Well, we screwed something up. But either way, there's going to be a pizza coming here. And they're going to call my phone. Hopefully my Google number works. All right, so we're going to leave this go because I don't want to break that. And we'll go to another example. Does anybody have any questions? I guess we should leave that out there. Like, if there's any questions ever, just raise your hands and one of us will notice. Go ahead.
Did you guys get rate limited by that?
So I think maybe. So what happened is, like, they didn't tell me. In this tracker thing, oh, it's still at 3 seconds. Crap, hold on. Let's make that 30, so 20 seconds. In this thing right here, where's like the header here? In that tracker part, we had to call every 3 seconds, and I was like trying on my laptop and trying on my desktop because something was going weird. We've also been having weird issues with the Wi-Fi at Pitt, so it wasn't working, and I couldn't figure out why. And I think what happened was I had it going so many times that I was getting rate limited because they just like cut the connection off with me. I was getting like a weird like 104 error, and it just said that the peer just decided to drop the connection, whatever. So I don't know whether either their system sucks. That's very possible. I can't imagine though because it's in production as far as I can tell. What I'm hitting is the one in production. So yeah, so I think that was their attempt. I think that was it because like gave it a while and then it worked just fine. But they didn't actually come back and say like give me like a 400 or something and say like, hey, you can't do this anymore. Yeah.
I'm just curious, like, I mean, you're fairly advanced, so how much time would it take to like, what you say to create, to figure this all out?
To figure this all out? I mean, it's going to take, a lot of messing around with a lot of different stuff, especially this one because, this is a fun example because it like affects change in the real world, so that's why we picked it. It's a horrible example because there's no documentation. I might possibly be breaking the law by doing this. No, I can't imagine. They left it open. But like, they don't publicly mention it. Like, I don't know if you have to like sign up with some developer account or something, but they don't even have developer accounts, sorry. You might have to be part of like some, corporation that makes, yeah. So that's the thing where like there's a lot of, there's not much documentation here, which makes it really hard. But I think what I tried to do is, I didn't read through all of it, but there's a crap load of comments in here that try and explain everything I'm trying to do. Some of our other simpler ones have better comments, and you'll see they'll make a lot more sense as a step-by-step learning example.
Would you say like a day?
To build this, like me?
Right.
Like, it took me like,
A project like this.
oh, like the pizza thing probably took me like, maybe like 2 hours. But
You really know what you're doing.
But yeah, like I've messed around with it a bit and had to like deal with some APIs that don't exist before.
He was really into this.
It was pretty. I have the receipt in my office still, dated with Python ordered pizza. But yes. But yeah, this is what Bob pays me to do. Not technically this. That's true. That's true. This was a little bit of work project. But on top of that, like dealing with these APIs is something I do all the time. So it's. But I think if getting started, it would, you'll see our other examples I'd say it would be like a day project, especially going through it. I think the most important thing to do with these is to take something that's already been made, especially code examples, and just modify them first. And just really just break them and figure out like why they broke. That's the best. That's how I learn everything. People learn differently, I guess, but like mainly it's like, sometimes look at the documentation and try and do it the right way, or sometimes I just try and find somebody who did something similar and then just change it to do what I want it to do and then find out why it doesn't, and then eventually you kind of just accidentally reverse engineer it and know it pretty well. But yeah. Mm-hmm. Yep.
The order plates URL that you guys have, that's the exact same construct that you use in a web browser too, right?
Yes. I would imagine, yeah, if you like whatever you do on their web when you order, will hit these API endpoints using probably fetch, the JSON library, the JavaScript library we talked about.
Yeah, if you go to anywhere.domino's.com, it's spelled ANYWARE, you'll find that they have lots of different ways that you can order pizza, like through Facebook Messenger and all kinds of integrations, and they can easily build these things because they have one API that they just have to build it into.
Yes, they just build an interface that just all of them use this. They all have a different interface.
And you guys didn't have to deal with any payment processors in this?
No, I don't. They handle that. So there's some key warnings in this script, like if you're ever using this My Binder, which in our thing we have links where you can run our Jupyter notebooks on the internet on just spun up servers in the cloud. I wouldn't recommend doing this because I don't know anything about those servers. Like this is running locally on my laptop, so that's fine. All of the requests I'm making are over HTTPS, so they're encrypted. With the only person that could read it is Domino's and So that's like so the person who did the node thing, and I linked to it, talked about something where like, yeah, you just send them a really basic representation of your credit card information and they do the rest. They probably send it out to somebody else's API who, works with, MasterCard's API that then gets the money from your bank, blah, 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 and it's just APIs all the way down.
Have you used the Postmates API?
No, I haven't, but that's another way to get human beings to bring stuff to you. Yes. All right, so while we're waiting on that pizza.
I think in the interest of time, we should probably speed through the other two examples.
Yeah, sure. Want to just do the Port Authority? Which one do you want to do next?
Yeah, I think it would be great to show everybody the Port Authority example. Steve made a real cool realization last night about how easy it is to do something with the Port Authority's API.
Yeah, so this one here, once again, we're just going to load up the libraries. This I actually got from Eleanor 2 weeks ago. It's this Folium library that puts maps into Jupyter Notebooks. And I realized when I saw that, I'm like, oh, this will be kind of sweet because I can kind of make a really crappy version of a one bus stop, one bus transit app. So here we just have, once again, set all our URLs up. You can see this. I don't have to tell you about it. You heard it enough. I'll make the request. Boom, we get this JSON. This is telling me where all the bus stops that I requested. And I looked it up on their map. It's the 7170C stop on Negley, right over there at the corner of Friendship, inbound to downtown. So, and then just picked 71A, as you'll see later, as an example. So yeah, so you can see here's like the stops URL. It says get stops. I'll send my parameters, so some basic parameters in the bus. And it says, okay, these are the parameters I'm sending. I make the request, and it says, okay, here's the response. Here's the stops. I only searched for one, so it's an array of one thing. And here's its latitude and longitude, stop ID, and its name, which is Negley Avenue with Friendship. So boom, now they have a prediction API. So I can use that with the stop ID to get a prediction of all the buses coming to that stop. So here's my parameters that I'll be sending, and I broke this all out so when you go through it yourselves, you can get an idea of exactly what's happening. So I make a request to the prediction API saying, hey, when are the next buses coming to that stop right there that are going inbound? So then it gives me a list of predictions. So the first one has a destination downtown. It's a 77, it's inbound, and it is predicted to be there at 7:47, which is like in a minute. And you can see there's a whole bunch. There's 71A, 71C, etc. So I want to filter that and say, hey, only look at 71As. So then I make a request of the prediction with that extra parameter that filters it a little bit more. And then boom, here's the next 71A that's coming to that bus stop. It's coming at what, 8:02. So I just want to filter that out, make sure I only have the first one. So this is that representation of that prediction, which I'm going to use in a little bit of code. So then also gave me the current time, which I have here, and I printed it in a nice format. Did the same with the prediction. Going to print the time just of the prediction so it's easier to read. And then I'm going to calculate how far out that is. So that's 16 minutes. I'm going to make a little message for myself that says, you've got time. The next 71A is coming at 20:02, which is in 16 minutes. If for some reason that happened to be less than 10 minutes, it would say better hurry up. And I'll put a link to this. I built an Alexa skill that it's really easy to build, where you can just say like, hey Alexa, when's my next bus coming? I use this in the morning because I'm lazy, and it gives me this message pretty much, except with the P3. So, and it's with a little bit of documentation I could put together, like anyone with like an Echo Dot or something like that could have it together in like an hour or so. All right, so here's with the Folium map. So I'm just going to zoom into where we're at here. I'm going to get the bus stop information, get the coordinates out of it, get our prediction, just to look at that again, and get the vehicle ID. This way we can get the location of the vehicle. So now I'm going to make a URL to get information about that bus, which has that vehicle ID. So I do that, boom. Uh-oh. Let's see. No data found, really.
Vehicle ID has disappeared.
I wonder if I screwed up. Well, I probably did. So if you look at our vehicle here, what was the vehicle ID? 6326. Oh, 62. Yeah, sorry, a little bit dyslexia there. But 6362. Ooh. Interesting. Dang. This is what happens when they change their API on you too. I don't get to actually spend much time.
Okay.
Well, we're not going to deal with this. But for some reason, their API, which tells me to request this bus, doesn't have any.
So if it had worked, we would see a map here with a marker showing the location of the bus. So we could update this as regularly as we want and get basically the essence of a little bus tracking app.
Yeah. So we'll leave that there. I was going to change to 77, but if you think we're going pretty long, yeah, we should probably just move to the next one. And the most important one.
I think we should skip.
Okay. Sure. This one?
I think we should go back to the presentation.
Okay. Sounds good. That is not the presentation. And that is not the presentation. This is the presentation. All right, so here we're just going to go over a couple things that are made with APIs. So a lot of you probably use transit apps. Those are all built using Port Authority API. They did a better job than I did with that thing, and I'm going to figure out why that didn't work. But then again, sometimes they don't, because I use this one for Android, and it kind of annoys me. But this is a bus ticker. So this is a little bus ticker I made with Raspberry Pi. And the little messages made from the Port Authority one. And then some folks in Bloomfield got excited about it and wanted to start putting them up. But then like last week, it fell in the middle of the night and set off their alarm, and the store owner that hosted it didn't like it. So we're figuring that out. But I think Lawrenceville has 3 they're about to have and put up. And hopefully we'll start seeing those. And if anybody actually ever wants to mess around with Raspberry Pis and learn how to mix all this together with Internet of Things stuff, I'd be happy to do something about that and show people more so that I'm not the only person that has to fix these things when they break out in the wild. And you also get to learn about these, and I don't know. Then you get to learn about Raspberry Pis, and they're fun. And then, so other things like tools of the data center that we've built, entirely built on top of APIs that we built to build our tools on top of, like a property dashboard. Those of you who've seen the city's bird's eye view, that entirely uses CCAN API. They make SQL queries, add our data, and then use it to populate this. And then they also use our property API for the bird's eye view parcels part.
Okay, so we're getting close to the end of this presentation, and you're going to have some time to work on things. We've put together a number of examples that you can sort of play with quickly. And at the data center, we have almost 300 data sets now with lots of interesting data. And some of those will be highlighted in the examples. It's very easy to get to it with using the CCAN API. I'm going to talk about a few possible data sets you could consider using and things you could do. All of this is in the README, so I'm not going to do it all. But we've recently gotten right-of-way information. This is basically when the city closes a road. And so this is updated on a regular basis. And so you could, if you want to know about road closures, you could pull that out and make notifications about that. We have a lot of different crime data and a guide that goes along with it. So we have daily records about arrests and non-traffic citations, a lot of police activity. And so it would be very easy to put together sort of a crime blotter just for your neighborhood, or maybe citywide based upon a particular kind of crime or category of crimes you're interested in tracking. Fire incidents. So every time the Pittsburgh Fire Department goes out and does something, whether they're rescuing a cat from a tree or putting out a cooking fire, it's in there. We have from the Big Berg app a regularly updated, a monthly updated list of all the social services provided by either the government or various charitable organizations to Pittsburgh and the surrounding area. And there's also lists of events in there. So that's something that gets updated and could be mined and posted to interesting places. The 311 data is one of the most interesting sets, and we have an example in one of the notebooks showing you exactly how you can pull out for a particular neighborhood or a particular type of request, say the most recent request. So you can find out where the last dead animal was reported in all of the city of Pittsburgh. Or you could modify things a little bit and find out about where potholes are being reported. There's even a status field, so you can find out which potholes have been dealt with and which ones have not been dealt with yet. Oh yeah, and certainly you could get 311 data and make a playlist out of it. I would love to hear that playlist. Our recommendation, we would like to see this happen, is you take all of the locations of the libraries and their hours of operation and use that to randomly select one and send the librarians a pizza.
Or you can send them to 3343 Forbes Avenue, care of Stephen Saylor.
Do we get to keep your credit card info?
Oh, we didn't do this.
What? No, we didn't. We got too caught up in the examples.
Okay. So I should probably call this, yes, question.
Can your data sets be combined with Mapbox?
With Mapbox, yeah, sure. Yeah, absolutely. We can talk about that later. So I probably should have just called this Quick Start. So we have a Jupyter notebook, but I have a 2-year-old and I've been reading Fox and Socks lately, so I called it Quick Trick Brick Stack. And the idea is you can put together some API bricks and some other codes of brick very quickly to have some outcome. That's the one. So if you go to this URL, github.com/wprdc/API-training, we have documentation on everything we described tonight, links to all these notebooks. There's these binder buttons which allow you to basically run this entire sort of folder of notebook examples, and you can click on the notebook you want to run. And the one I recommend, if you have no ideas about what you want to do, and you just want to get your feet wet, I would recommend the Quick Trick Brick Stack. Okay, so finally, this is the last slide for now. What are we going to do in the remaining time? You're going to have time to do whatever you want, to experiment. We're going to be circulating around to try to provide help. I don't know if there's going to be time left for a live coding stunt, but if anybody has a particularly interesting but maybe not too difficult question, we might do that. And finally, at the end, we're going to do a wrap-up. We're going to ask people, what did you learn tonight? What are you interested in doing next? And we will have prizes. Oh yes, I forgot. We have noids as prizes, not just one. These cost hundreds and hundreds of cents on eBay. Okay, so that's all for now. Any questions at this point? No. All right, the pizza's going to come soon, probably.
Hopefully.
Thank you.